Chapter 1. Concepts. We all know that the matter is made up of atoms. These atoms were once considered indivisible, but in reality, atoms are made up of more fundamental particles. In this study, only the protons and electrons are of more importance. Atoms combine with one another, and forms everything we see. Atoms affect each other by producing a field, primarily electric field. This is one of four fundamental forces in nature. These interaction between the atoms is known as intermolecular forces, as they operate in molecular level. Modeling the exact nature of force between two atoms is complicated, as this is not the classical physics. This requires quantum mechanics. Making a simplified analysis, we come up with what we called potential energy function. As this is conservative field, we can obtain the force. This function describes the force between two atoms. When we fix one of the atom at the origin, and bring the other atom in the vicinity of the other, the point where the potential energy reaches minimum, we say the atom is bonded with the other, and the internal force between them becomes zero. In this position, attractive forces between the nucleus of one atom and the electrons of the other balances the repulsive forces between them. So this is the distance between the atoms at 0 Kelvin. Because the temperature introduces the kinetic energy, and the distance changes, which is the precise reason for the thermal expansion. So let's say this is the same distance in this case. In this minimum potential energy state, the system is in stable equilibrium. If we increase the distance, the restoring force develops. For understanding this force, we assume the atoms are connected with the hypothetical springs, with the atomic distance as the natural length. If we apply a force, then the distance between them changes, and the restoring forces develops, and tries to bring the system to the minimum potential state. This internal restoring force, my friends, is called stress. And the change in atomic arrangement is known as strain. So, we can see that the restoring forces appeared when there is change in arrangement. It means stress is a function of strain. Strain comes first, as a matter of fact. Stress can be defined as the internal restoring force acting per unit area. Remember, internal is important. And the role of area in defining stress is quite obvious, because not only the amount of the external force, but also the area over which it is acting is important. Let's see a case where equal amount of external applied on different area. It is clear from the example that the internal forces is different, which is important. By dividing with area, we are somehow measuring the internal force between each single atom. Okay, what type of quantity is stress? A scalar, or a vector? All that I can say is that it is a tensor quantity. That's it for this video. In Chapter 2, we are going to relate the stress and strain mathematically, using the concept of continuum. If you like this video, consider subscribing the channel.